Now see the case of a serial port where combined operation is possible, that is input and output operation is possible. So what is serial port? Serial port means the interaction with device is in serial fashion. Okay, so or the entire interface, that is the serial interface, will communicate with device in serial fashion. And the diagram shown here is of a serial I/O interface. So input and output is both possible. So if you consider a device is sitting over here, maybe a dial-up modem. Okay, it can supply data packets to the master or to your CPU, and that will be in serial way to the interface. Okay, to the interface or the input interface of the dial-up modem. The modem will be supplying the bits in serial fashion. Okay, one after another. And similarly, in case of an output, or when the CPU or the master wants to send something to the network, it will be pushing it to the modem in serial way. Okay, bit by bit. Okay, so that is serial output. So let us first see what are the major parts of this interface. So the first main part is your shift registers. And what is the purpose of shift registers? If you observe here, the interface acts as a parallel port towards the CPU or the master, or it supplies data to the CPU or the master in parallel fashion, but to the device it is a serial interface. So in order to facilitate conversion between the serial input or the serial output to the device and in a parallel way to the master, these shift registers actually exist. Okay, so these shift registers are the first critical components of a serial port, okay, or a serial interface, and the main role is to convert serial input or serial output to the required fashion as demanded by the master or by the device. Okay, the master requires data in parallel fashion, so this input shift register will accept it in serial form and will convert it to parallel form for the master to read. And when the device requires something in serial format, the interface will read it from the CPU or the master in parallel format, and it will convert it into serial format and supply to the device. Okay, so shift registers are the first critical components required for a serial interface, and the rest of the things are common across all interfaces. If it is a I/O interface which can perform both input and output, you should have a input data register to hold the information from the device. Then you should have a output register to hold data from the master or CPU to be supplied to the device. Then you should have sufficient circuits for address decoding, and we have seen address decoder circuit in many interfaces, right? What the address decoder does, it will give a high signal, or it will get activated whenever this corresponding interface's address is put by the master on the bus. Okay, so that high signal is supplied over here to a combined circuit known as chip and register select, and so that is the address decoding part. Then the remaining thing is regarding the status and control registers. So as it is an I/O interface, it should definitely show the status of its input and output. So SIN and SOUT bits will be there, and apart from that, other status bits will also be there based on the device. So we need to actually supply that status information to the master, right? So those information will be actually multiplexed over the same lines for the master, that is from D0 to D7. Okay, these lines are again used for actually input and output for the master. Then we have ready and accept pins, and these pins are used for asynchronous data transfer, as we have seen in master slave protocol. Then we have a read write pin, which indicates the operation that is to be performed by the I/O device. Then we have two pins, RS1 and RS0, which are known as register select pins, and this will help us to select the required component within this interface for a read or write operation. So here how many components will be there at a minimum? If you see here, we have a data input register, data output register, and status register, definitely, right? So at least three components are there, and in order to uniquely address these three components, we will definitely require how many bits? 2 bits, right? So for that we have RS0 and RS1. Okay, so these are the important components within this serial interface. And similarly, the serial interfaces or serial IO is characterized by clock. Okay, along with the transmitted bit, there will be clocks. There will be a clock signal telling the meaning or the timing information of each bit. Okay, so for actually for there will be multiple clocks for different purposes, and here we have a receiving clock for input and we have a transmission clock for output, and that is the main distinguishing feature of this serial interface with parallel interface, right? So that part is handled by the status and control unit or status and control circuit. So these are the main parts of a combined serial interface, and we will see how input and output happens. So this is this combined interface in input mode. So what is input mode? Here you have on the right, here you have a device, an IO device, say dial-up modem, which is trying to supply packets to the CPU or the master, right? So what the device will do, it will try to supply the bits one by one, and that will be accepted by the input shift register of the interface. As I told you earlier that this interface communicates with the device in serial fashion. So once this input shift register's capacity has been reached, okay, let us assume that this input shift register is of 8 bits. So once this capacity is reached, what happens? The contents of this shift register will be transferred to the input data register or data in. Okay, so the device will be putting the bits one by one onto input shift register. So here the transmission is serial, but once that operation is complete with the input shift register getting filled up, the contents will be transferred to data input register. Okay, and from here on, that is from stage 2 to 3, everything is going to be parallel. Okay, so whatever thing is there in data input register, that can be read by the master or the CPU in parallel fashion from these tri-state buffers corresponding to the individual bits of data in. Okay, we have seen this arrangement earlier. So there will be a signal going from chip and register select to the control inputs of all these tri-state buffers whenever a read operation is triggered and a ready signal is given to this interface. Okay, so at that time this will be available across D0 to D7. The data present in data in register will be available at across the pins D0 to D7, and transmission to the master happens. Okay, so here is how an input operation takes place in case of a serial interface. So note that in stage 1 the transmission is serial, but from stage 2 to 3 we have an arrangement for parallel transmission to the CPU or the master. Okay, so if you see here, once the device puts the data into input shift register, and the data is after the data is transferred to data in, this input shift register is actually vacant. Okay, at that time what the device can do, it can put the next sequence of bits into the input shift register and wait for the device to clear the contents of input shift register. So what happens in such an arrangement is, at a time maybe 2 words of transmitted data from the device can be held in the interface, one in the input shift register and other the previous thing that was held by the input shift register and now shifted to data in. Okay, so that can be one of the distinguishing features of a serial interface, where data in and input shift registers are separate components. Okay, in certain interfaces this data in itself will be a shift register the register capable of supplying output in parallel fashion. So in such a case only one word at a time can be accepted by the interface. Okay, so this is how input operation happens. Now we will see how output operation happens. So for output operation, the CPU or the master will put data across D0 to D7 lines in parallel fashion, but we are dealing with a serial device, right, a modem. So we need to convert it to, or the interface needs to convert it to serial fashion. So what the interface will do, it will accept the data from the CPU or the master in parallel fashion into a separate register. Okay, data output register. And what happens next, data output register will be moving the contents to a shift register, which is named as output shift register, which is capable of shifting the bits individually to the device in a serial fashion. Okay, so in stage 1 we have a parallel input operation from the CPU to the interface, and that operation is complete with stage 2, where the data is loaded into data out. Now from stage 2 to stage 3, again a parallel writing into the output shift register happens, and in stage 3 serial shifting out of the bits in output shift register happens, and the device finally receives the data supplied by CPU or the interface in serial fashion. Okay, note that when the CPU is doing an output operation, or the master is doing an output operation, what might be the RW signal? It will be 0, right? We are going to write to the device, so it will be 0. Then similarly ready should be activated, indicating that the master is putting valid address and command, and again the address, my address, should be 1, saying that this interface has been selected, and the RS1 and RS0 should be such a way that data out is selected, right? So this is how output happens in a combined serial interface.